start with the important skill of measurement. And the key to measurement is that we have to use instruments. Now I'm going to draw, there's a stick. That's a great looking stick. If someone walks up to it, they could say, oh, it's a pretty long stick. Or someone can say, it's a short stick. That is not very quantitative. So when we use instruments, we use instruments to increase our precision in our measurement. We can say more things. We have more information. The more expensive the instrument, usually that's the key to knowing it's going to be more precise. It's going to give us more information. If we look at this piece of a ruler that I have in the right side here, you will see, and again using your senses observe, you'll see an upside down 11, 12, and that distance from 11 to 12, it doesn't have it there, but that is a 1 inch distance, 1 inch. And it's divided into some intervals. But that distance is 1 inch. If you read up from the 11, and just draw an imaginary line up from the 11 on up to where it hits on the metric ruler component, you will see that 1 inch will hit at about 2.54 centimeters. That is our conversion factor that you should know your whole life, because we don't deal with centimeters enough, but the rest of the world does. 1 inch is 2.54 centimeters. That's a conversion factor. Another thing you'll observe is that in the instrument on the top, it goes from 1 centimeter to 2 centimeters, but it's divided into 9 lines there, which will give you 10 intervals. So the smallest division on this ruler, and this is a good word, 2 words I guess, to know, is least count. Least count is the smallest measured interval. Okay, least count, smallest interval. So the smaller the interval, the greater the precision, and again the greater the expense. Least count. This is also a measure of what we call our degree of uncertainty, how well we can measure. For instance, on our instrument, if we look at the number 2 in the top, okay, now you start reading over the intervals. 1, 2 intervals. If you read to the second interval, you have a measurement of 2.2 centimeters. 2.2 centimeters. Remember, this is a quantity. This is a number plus a unit. 2.2, that means we are placing value on the 2. We read it directly, and we're placing value on the second interval between the 2 and the 3. So in terms of talking about it, we can say there are 2 significant figures here, or the small sf. But if we read 2 and looked over to the second interval, 2.2, and we estimated the space in between, now this is the space in between one of these intervals, there's no line there, and we could say it's 2.25 centimeters. Now we are actually still doing something that's very important, because we're estimating between plus or minus 0.01. We're estimating to hundredths. In other words, this measurement here, we're saying could be as much as 2.26 or down to 2.24. Okay. This is still called a significant figure because even though we have uncertainty, we place value on it. However, if we put down 2.253 centimeters, we can estimate at this point only. We can't estimate within an estimate. We can't take an imaginary no lines and divide within those no lines. So we can't go beyond the precision of our instrument. So this digit here is not a valid digit in our measurement. And again, we're limited to plus or minus 0.01, which would give this, again, 3 significant figures. If we read to 2.0, that means we observe that number, large number 2, and the starting line is synonymous with that 2. That value is read directly to significant figures. Or if we would read 2.05, that means these two are significant, and this is an estimate. It's also significant. We have 3 significant figures. We have not gone beyond the precision of our instrument. Therefore, notice that 0 is significant here, just as this 0 up here is significant. A rule is all zeros to the right of a decimal place are significant. That means they're measured. Or if there's a 0 embedded between 2 numbers, that is significant. But very quickly, and this is going to be a little silly, if we put down 2.5 centimeters, that value is 2.5 centimeters. 0 doesn't add anything to it. So zeros to the left of a number are not significant. Okay. I think that we will stop right there and just summarize, first of all, that instruments have precisions, and the least count is the smallest interval. The number of significant figures are those that we place value in. We can't be more significant than our instrument allows us. Zeros within numbers are significant. Zeros at the end of a decimal point are significant. Zeros in front of a digit are not significant. So we'll stop there, and I suggest strongly that you go immediately to Measurement.Significant Figures 2, and we'll start using these measurements and these numbers in some small activities. We'll stop there.